Good day, class. So here's the continuation of our module 2. So for this module 2, we will be solve a sample problems about strain. So our first problem will be the steel propeller shaft ABCD carries the axial loads shown in the figure. So determine the change in the length of the shaft caused by these loads. So use E or Young's modulus ng steel, that is 29 times 10 raised to 6 psi. Okay. So before we solve it, i-derive lang natin yung formula na gagamitin natin, no? So yung change in length, so determine the change in the length of the shaft caused by this these loads, okay? So yung change in length natin, okay? So that is the equal to our elongation, yung elongation ng ating material, di ba? And sabi natin, strain is equal to the elongation over yung length ng material natin. Okay? And yung stress natin, sabi natin, stress is directly proportional siya doon sa ating strain. Okay? So, kung lumalaki yung stress, lumalaki rin yung strain. So, para maging equal sign ito, so kailangan natin mag-introduce ng constant, which is yung E, that is the same sa ating yung properties ng ating material. Okay? So, that will be stress is equal to, so yung constant natin na E multiplied by the strain. Okay? So, and sabi natin yung strain that is equal to, so dito tayo, that yung strain is equal siya sa elongation over L. So that will be times E. Ayan. And para makuha natin yung elongation, so usin lang natin yung equation natin. So cross multiply, that will be stress times yung length, that is equal to the elongation multiplied by the Young's modulus E. And sabi natin yung stress, that is equal to P over A. Tama? So ilipat muna natin, ihiwalay natin yung elongation, no? Kasi yun yung hinahanap natin, no? So that will be i-divide natin both sides by E. So cancel yung E dito, ang matitira is yung elongation, that is equal to the stress times L over E. Okay? And sabi natin yung stress natin, stress is equal to force over area. So therefore yung elongation natin, i-substitute lang natin doon. Elongation natin, that will be PL over AE. Okay? So ito yung formula na gagamitin natin, no, in determining the change in length of the shaft. Okay? Okay, class, so let us solve na yung ating problem. So first is kailangan natin kunin yung internal force na nag-act sa ating mga segments. So for segment AB, that is equal to 2,000 pounds. And for segment BC, so section natin along BC, and summation of horizontal forces. Therefore, kung 2,000 pounds yung nag-act sa point A, 2,000 pounds din yung nag-act sa segment BC. Okay, so that is also tension. And for segment CD, so kailangan natin i-section and isolate natin yung nandito sa right side. Okay? So if 4,000 pounds yung nag-act at point D, therefore sa internal force ng segment CD natin will be also 4,000 pounds. Okay? So in getting the change in length of the shaft caused by these loads is yung summation lang nung effect nung change in length nung tatlong forces natin. Okay? So since yung E natin is constant sa steel lahat yung ating system, no, yung ating shaft. So sabi natin elongation. Okay? So elongation is equal to the force times the length over yung area times yung Young's modulus. So ang gagawin lang natin is yung summation actually nung ating elongation through ng gagawin ng effect ng ating force ABN, BCN, CD. Okay? So that will be yung summation lang niya. So that is equal to, so constant naman yung E natin, no, na 29 times 10 raised to 6 psi. So, pwede natin siyang ilabas. Okay? So, that will be equal to 1 over E times yung effect ng force na 2,000 pounds. So, that will be PL over A, cost ng segment AB, plus force times length over A, cost by force BC, plus force times L over A, caused by force CD. Okay? So, kung mapapansin nyo ito, this is compression, no? This is compression, this is tension, yung dalawa. Therefore, kung pag compression, yung gagamitin natin na sign will be negative. So, actually, this is minus, no? For the segment CD, that is compression. So, ima-minus natin. Okay? So, i-substitute na lang natin. So, substitute nyo na lang. So, ang lalabas dito, that will be elongation will be equal to 1 over 29 times 10 raised to 6 multiplied by yung force natin na 2,000 pounds times yung length niya. So, 5 feet. So, take note of the unit. So, ang gagawin natin is, so PSI, naka-inch dapat yung ating length. So, that will be yung 5 feet. I-multiply lang natin siya ng 12, no? Kasi in 1 feet, there is 12 inches, no? So, i-multiply natin siya ng 12 inches. So, that will be over yung area niya. That is 0.5 inch yung at kanyang diameter. So, yung area will be pi over 4 times 0.5 squared. Okay? Plus, yung force for BC, that is also 2,000 times yung length. So, yung length natin for BC is 4 feet. So, 4 times 12 over yung area niya. So, pi over 4 times, so the diameter is 0.75 inch. That will be 0.75 squared. Minus, yung last segment natin, that is 4,000. Times, yung length is 4 feet. So, that will be 4 times 12 over yung area niya, 0.75 then. So, pi over 4 times 0.75 squared. Okay. Therefore, yung elongation natin, that will be equal to 0.01358 inch. Okay? So, yan yung acting final answer for the change in length caused by these loads. Okay, for the next problem. So, the cross-section of the 10-meter long flat steel bar AB has a constant thickness of 20 mm, but its width varies as shown in the figure. So, calculate the elongation of the bar due to 100 kN axial load. Use E is equal to 200 gigapascal for steel. Okay? So, sabi natin, elongation is equal to force times the length over area times the Young's modulus, E. Okay? And in this case, yung area natin is hindi siya constant. So, it varies all throughout the length. Okay? So, we can use yung algebra natin, no, in determining area. So, we can determine the area as a function of x. Okay? So, first, meron tayong area at point A, no? So, area at point A, that is equal to 40 times 20. So, that is equal to 800 mm squared. And for area at point B, that is equal to 120 times 40 is equal to 2,400 mm squared. Okay? So, kung makikita nyo yung length at area A, so at x is equal to 0, So yung area natin is 800 mm squared. And at x is equal to 10 meters. So yung whole na 10 meters ng bar. So at x is equal to 10 meters. Yung area natin, yung cross-sectional area niya na will be 2,400 mm squared. Okay? So we can use yung ating algebra o yung tinatawag na, if you remember, yung point slope form. Okay? So that is equal to y minus y sub 1 is equal to yung slope niya, slope of a line, times x minus x sub 1. Okay? And yung area natin kasi is directly proportional siya doon sa kanyang length, no? As the kapag tumataas yung area natin, no? As the area increases, also the x axis will also increases, the length also increases, tama? So we can find the slope, no? So yung slope of a line, that will be equal to y2 minus y sub 1 over x2 minus x sub 1. So yung slope natin actually, so yung y natin, ito yung area, okay? So let's consider the y to be the area, okay? So let's call the area B to be the y2, okay? So yung slope natin, that will be 2,400 minus y1, that is yung area A, 800, over x2, that is 10 minus 0. Okay? So substitute lang natin yung dito, no? So let's consider na yung y will be yung area natin, no, for the kwan. So y will be yung area natin. So that will be area minus yung y1 natin, consider natin, that will be 800, no? Yung ito yung y1 natin. Tama? Yung 800, that is equal to the slope. So that is 2,400 minus 800 divided by 10. That is equal to 160 times x minus our x sub 1, that is 0. Okay? So actually yung ating equation, that will be equal to, i-simplify lang natin, ialisin natin yung area, iwan natin yung area dito sa left side. So that will be equal to 160 x plus 800. Okay? So ito yung magiging equation natin. So this is unit nito will be times 10 raised to 6 negative 6. So this is naka mm squared kasi siya, kaya i-convert natin into meter, square meter. Okay? So yan yung magiging area natin. So we can now solve yung ating elongation using yung ating integral, no, differential L, no. So magkakaroon tayo ng differential na elongation, that is equal to P over L AE. So yung actually magkakaroon tayo ng differential length dito, no, kasi nagbabago yung length natin or yung x natin. So we can rewrite it as the differential elongation is equal to P over AE differential x. So we can change this as dx. Okay? So ang constant natin is yung force and yung E. Tama? So pwede nating ilabas yon, no? So para mawala yung differential natin, so we need to integrate it, no, both sides. So matitira na lang dito, that will be D is equal to the differential constant, yung P and E natin, tama? So pwede natin siyang ilabas, so that will be P over E, so the integral of 1 over yung area dx. So we can substitute. So this one is yung elongation natin, no, pala. So elongation is equal to P over E, the integral of 1 over A dx. Okay, so substitute na lang natin. So elongation is equal to, so ano yung force natin? That is 100 kilonewton. So that is equal to 100. So times 10 raised to 3 para maging newton over yung E natin na 200 gigapascal. So that will be 200 times 10 raised to 9. Okay. The integral of, so ito is yung from 0 to yung ating length. Okay. So from 0 to 10 meters, no? Para makuha natin yung whole from the 10 meters. So that will be 1 over, so yung area natin, that is equal to 160x plus 800 times 10 raised to negative 6. That is equal to 160x minus 800 plus 800. This is times 10 raised to negative 6 dx. Okay, so we can actually input directly the equation into our calculator. Kung merong integral function yung kanyang inyong calculator, if you are using fx991es or es plus, so that will give us the elongation will be now equal to 3.43 mm. Okay, so this will be the elongation due to the 100 kilonewton axial load. Okay. So for our next problem, so the concrete post in figure A is reinforced actually with 4 symmetrical placed steel bars. So each of cross-sectional area 900 mm squared. Compute the stress in each material when the 1000 kilonewton axial load is applied. So the module of elasticity are 200 GPa for steel and 14 GPa for concrete. So we have a reinforced concrete column here subjected to a load of 1000. So let us compute for the stress. So we can have the equilibrium equation. So yung pwede natin gawin is summation forces vertical is equal to 0. For the system to be equilibrium, so let us sum the forces vertical is equal to 0. So sum the forces vertical is equal to 0. Going upward is positive. So meron tayong yung concrete natin and steel will resist a 1000 kilonewton. So that will be force due to concrete plus force due to steel. So that is equal to, ilipat na natin sa kabila, 1000. So times 10 raised to 3 newton. Okay, para maging newton na. And sabi natin stress is equal to force over area, no? So for force, that will be equal to stress times area. So that will be stress nung concrete times yung area nung concrete plus stress nung steel times yung area nung steel. That is also equal to 1000 times 10 raised to 3 newton. So meron tayong equation dito with two unknowns. Okay. So, paano natin makukuha yung stress? So, we can get the stress using yung ating deformation, ano? So, for the deformation to be compatible, so kailangan yung deformation ng steel is equal to the deformation ng concrete, okay? So, kung itong concrete column natin will deform, no? Due to the axial load, so magkakaroon ng change in length, no? Magde-deform yung ating concrete column and steel. So for compatibility, yung deformation ng concrete is equal sa deformation ng steel. Tama? And sabi natin deformation is equal to, so deformation is equal to PL over AE, no? And yung P over A natin, that is also equal to stress. Tama? So, deformation is equal to stress times L over E. Okay. So, i-substitute natin ito dun sa ating compatibility equation. So, that will be stress and length and E ng ating concrete, that is equal to, so ito yon, equal to stress and times length over E ng ating steel. So ayan, yung length natin is same lang din, di ba? So same lang, so compatible sila. So kung nag-deform yung ano, so yung length natin is constant, isa lang, kaya magka-cancel yung length natin, tama? So yung matitira na lang will be stress ng ating concrete over E ng concrete, that is equal to stress ng steel over yung E ng steel, tama? So makakagawa tayo ng isa pang equation. So yung stress ng concrete natin is equal siya sa E concrete times the stress ng steel over yung E ng steel. And given yung E ng concrete and steel natin, and so for concrete that is 14 gigapascal. So for stress ng concrete is equal to yung E concrete natin, that is 14 gigapascal times yung stress ng steel over yung E ng steel, that is 200. Tama? So we have 14 over 200 times stress ng steel is equal to the stress ng concrete. Okay? So we can substitute na lang ito sa ating equation. So 14 over 200, that is equal to 0.07. So actually yung stress ng concrete natin is equal to 0.07 times the stress of the steel. So i-substitute natin to sa ating equation 1. So this is our equation 2. So substitute natin sa equation 1. So sa equation 1 natin, so i-rewrite natin yung equation 1 natin, that will be stress ng concrete times area ng concrete plus stress ng steel times area ng steel. So that is equal to 1,000 times 10 raised to 3. So yung stress ng concrete natin, that will be 0.07 stress ng steel. Okay? So that will be, i-substitute na lang natin itong stress ng concrete, palitan natin gawin in terms of stress ng steel. So that will be 0.07 stress ng steel, no? Times yung area ng concrete natin. So yung area ng concrete natin is 300 by 300, and i-minus natin, i-deduct natin yung area ng steel. Okay? So meron tayong 4 reinforcing steel bar with an area of 900 each. So i-less natin yung area ng steel. So for area ng concrete, that is equal to 300 by 300 minus yung area ng steel. So that will be 4 na steel bars times yung area nila is 900 mm. So that will be 900. Okay, so yan na yung area ng concrete natin, no? Plus stress ng steel times yung area ng steel, that is 900 times 4. So 4 sila. So that is equal to 1,000 times 10 raised to 3. So that will give us, simplifying yung ating equation, so it will give us yung stress ng steel natin is equal to 103.6484 megapascal. Tama? So ito na yung stress ng ating steel. And for the stress ng ating concrete, so that is equal to stress ng concrete is equal to 0.07 stress ng steel. So that will be times 0.07 lang. So stress ng concrete natin is equal to 7.255 megapascal. Okay? So this will be our final answers. So next problem tayo. So a figure A shows a rigid bar that is supported by a pin at A and two rods, one made of steel and the other of bronze. So neglecting the weight of the bar, compute the stress in each rod caused by the 50 kilonewton load. So using the following data, given yung area and modulus of elasticity ng steel and bronze. So for our free body diagram, we have the bar supported at point A. So magkakaroon tayo ng horizontal and vertical reaction at point A, no? And magkakaroon din tayo ng reaction at steel and bronze. So meron tayong 4 unknowns and only 3 equations sa ating equilibrium, di ba? Summation of forces horizontal, vertical, and summation of moment. Now, yung equation na mabubuo natin without getting the reaction at point A is we will take summation of moment at point A. Okay? So if we take summation of moment at point A, will give us the force steel and force bronze. So that will be summation moment at A is equal to 0. So gawin na lang natin clockwise, positive. So counterclockwise yung rotation ng ating reaction ng force sa steel and bronze. So they are both negative. So that will be negative force ng steel times yung distance niya, that is 0.6, minus force ng bronze times 1.6 distance niya, plus yung 50 kilonewton natin multiplied by yung distance niya, which is 2.4. Okay? So that is equal to 0. So i-simplify na lang natin yung equation natin. So that will give us 0.6 force ng steel plus 1.6 force ng bronze is equal na siya sa 50 times 10 raised to 3 times yung 2.4. Okay? Or that is equal to 120 times 10 raised to 3. Okay? So 0.6 plus 1.6. So this will be our equation 1. Okay? So meron tayong isang equation with 2 unknowns. So kailangan nating bumuo pa ng isa pang equation. So we can solve it as 2 equations and 2 unknowns. So we can use the compatibility principle in getting the deformation. Okay, in getting the stress. So sabi natin magkakaroon tayo ng deformation. So ito yung magiging deformation ng ating bronze and steel due to sa load na 50 kilonewton. So bababa yung ating bar, no? So magde-deflect yung bronze at a distance dito and yung steel natin. Okay? So makakabuo tayo ng triangle. So exage lang natin na ganyan. Magiging parang triangle yung itsura niya. Yung from the original position, so bababa yung ating pinakadulo due to the 50 kilonewton. And meron tayong deformation ng bronze and deformation ng steel. Okay? So kung makikita nyo, nakabuo tayo ng triangle. So we can use the properties ng ating triangle, similar properties. So for the similar properties, so yung ratio and proportion. So kung itong side, yung maliit na triangle natin, so that will be the deformation of steel over yung distance niya from point A, 0.6. So that is equal to yung deformation ng bronze natin over, so yung distance niya from point A, so that is 1.6. So that is ratio and proportion, ano, sa ating algebra. So ngayon, pwede nating meron na tayong 2 equations and 2 unknown, no? In this case, kunin natin yung force ng steel in terms of bronze, okay? So sabi natin the deformation is equal to PL over AE, okay? So that pwede nating i-substitute yung PL over AE sa ating stress. So that will be equal to PL over AE over yung 0.6. So that is equal to PL over AE over 1.6. So this is for steel and this is for bronze. Tama? So given na yung ating force, given na yung length, area, and E nung ating steel and bronze. Okay? So i-substitute na lang natin. So i-simplify natin yung ating equation. So that will be force ng ating steel so i-simplify natin yung equation natin. So actually itong 0.6 is tataas na lang siya, no? So that will be 0.06 times PL over AE is equal to 1.6 times PL over AE nung ating bronze, and this one is for the steel. Okay? So substitute natin yung length, area, and yung modulus of elasticity for both steel and bronze. So that will be 0.6. So force ng steel times yung length ng steel. Ano yung length ng steel? That is 1 meter. So 1 meter over yung area ng ating steel, that is 600. So 600 times yung E nung ating steel, that is 200. Okay? That is times 200. So that is equal to 1.6 force ng bronze times yung length ng bronze, that is 2 meters. So multiplied by 2 over yung area ng ating bronze. So that is, the area of our bronze is 300 and 83 yung kanyang E. So that will be 300 times 83. Okay. So we can solve yung ating force steel in terms of force ng bronze. Tama? So simplify natin yung equation natin. That will give us P is steel is equal to 3.614 ng bronze. Tama? So this will be our second equation. So kapag sinubstitute natin yung value ng P steel doon sa first equation natin dito sa moment, okay, so that will be will give us yung magiging force ng ating steel will be equal to 115.08 times 10 raised to 3 Newton. So kapag sinubstitute na natin yung force ng steel dito, so that will be give us force ng bronze will be equal to 31.84 times 10 raised to 3 Newton. Okay? So makukuha na natin yung stress in each material. So for stress ng steel, that will be equal to force over area ng steel. So that's equal to 115.08 times 10 raised to 3 over 600 times 10 raised to negative 6 para maging meter siya, no? Square meter, and ito is magiging Newton. Therefore, stress ng steel natin is equal to 191.8 megapascal. Okay? And for the stress of the bronze, that will be equal to the stress of bronze. So, force over area ng bronze and steel ay ng bronze. So, that will be equal to 106.1 megapascal. Okay? So, substitute nyo na lang yan. So, same lang din. So, this will be our final answers. So, next problem tayo. So, this is a example of a thermal stress problem. So, involving yung ating temperature change. Okay? So, the horizontal steel rod, 2.5 meter long and 1,200 mm in cross-sectional area, is secure between two walls as shown in the figure A. If the rod is stress-free at 20 degrees Celsius, compute the stress when the temperature has dropped to negative 20 degrees Celsius. So assume that number 1, the walls do not move. And second, the walls move together at a distance delta is equal to 0.5 mm. So use alpha is equal to 11.7 times 10 raised to negative 6 per degree Celsius, and E is equal to 200 GPa. Okay? So meron tayong steel rod dito, no? Supported by a wall in between left and right. Okay? So pag na yung temperature is na bago, no, bumaba ng negative 20 degrees Celsius, so magkakaroon tayo ng deformation due to temperature. Okay? So para maging mabalik siya, no, yung hindi siya mag-move yung ating walls, so kailangan din natin ng force P. Okay? So sabi natin for compatibility principle, for the structure to be compatible, yung elongation due to temperature will be equal to the elongation due to the force P. Tama? So sabi natin, yung stress due to temperature, that is equal to alpha times yung change in temperature multiplied by the length. Okay? And yung strength due to force natin will be equal to PL over AE. So we can substitute that doon sa ating compatibility equation. Tama? So if we substitute that, it will give us, that will be alpha times the change in temperature multiplied by L is equal to PL over AE. Right? So yung L natin is constant. So magka-cancel tong L natin. Tama? So kapag yung, and yung P over A natin, that is also equal to stress. Tama? So that will give us alpha times change in temperature, that is equal to the stress over E. Okay? So for the stress, para makuha natin yung stress, so that will be stress is equal to alpha times change in temperature times yung modulus of elasticity, that is E. Okay? So substitute na natin yung given natin. So first, the walls do not move. So the for the situation 1, no, the walls do not move. So if walls do not move, so yung length niya ng ating rod, so the same siya kasi hindi gagalaw yung ating walls. So intact pa rin siya. So that will be stress will be equal to alpha, that is 11.6, 11.7 times 10 raised to negative 6 times yung change in temperature niya. So ang normal temperature natin is 20 degree Celsius. So stress-free siya at 20 degrees Celsius. So yung change in temperature, so nag-drop siya na into negative 20. So that will be 40 yung kanyang change in temperature. Tama? So 40 multiplied by yung modulus of elasticity, that is 200 times 10 raised to 9, no? Para maging Pascal. So that will be stress will be equal to 93.6 megapascal. Okay? So this will be our stress if the walls do not move. So yung situation 2 natin, that will be the walls will move together at a distance delta is equal to 0.5 mm. So yung figure natin will be, so if yung rod natin, so magkakaroon siya ng deformation due to the temperature. And for the compatibility, so that will be, magkakaroon tayo ng deformation due to force P plus yung kanyang delta, no, na 0.5 mm. Okay, so nag-move yung wall natin. Okay, so that will be for compatibility, that will be deformation ng due to temperature is equal to deformation due to actual load na P plus yung delta natin, which is yung 0.5 mm. Tama? So for deformation is ng due to temperature, so that will be equal to alpha times delta T times yung length ng ating rod is equal siya sa yung deformation ng due to P, that is equal to PL over AE or stress over L over E, plus yung ating delta, no? So that will be i-compute natin yung ating stress. So ilipat natin yung stress sa kabila. So ayusin lang natin yung equation natin. So that will give us a stress will be equal to E multiplied by the alpha times delta T minus yung delta over L natin. Okay? So you can directly input ito sa calculator. So if you simplify this, ilabas niyo yung stress dun sa right side and laruin nyo lang yung equation. So it will give us this equation. Okay? So substitute na lang natin. That will be stress is equal to yung E natin, 200 times 10 raised to 9 times 11.7 times 10 raised to negative 6 times yung change in temperature. So that is still 40 minus yung delta natin will be 0.5 mm. So that will be convert natin siya sa meter. So that will be 0.5 times 10 raised to negative 3. Okay, para maging meter, divided by L, which is yung 2.5 meter. Okay. So yung stress natin will give us a stress of 53.6 megapascal. Okay, so this will be our final answer. Okay, for our last problem. So figure A shows a homogeneous rigid block weight 12 kips or 12 kilopounds that is supported by 3 symmetrical place rods. So the lower end of the rods were at the same level before the block was attached. So determine the stress in each rod after the block is attached, and the temperature of all bars increases by 100 degree Fahrenheit. So use the following data. So given na yung area, modulus of elasticity, and yung alpha ng ating material ng steel and bronze. Okay, so we have this figure, rigid block supported by steel, bronze. So calculate the stress in each rod after the block is being attached, and the temperature of all bars increases by 100. So due to temperature is magkakaroon tayo ng elongation, and due to the force ng ating weight, due to the weight ng ating rigid block, so magkakaroon din tayo ng deformation. Okay? So ito yung magiging free body diagram natin, no? Due to the load na ating 12 kips, so magkakaroon tayo ng deformation due to the force ng steel, and deformation due to the temperature ng steel. And ganoon din for the bronze. So for compatibility, dapat same sila, no? Same level sila. Parehas yung elongation ng ating steel due to temperature, plus yung ating elongation due to dun sa force. Okay? So for compatibility equation, that will be yung force deformation ng ating steel due to temperature, plus yung deformation ng ating steel due to the force, that is also equal to, so for the bronze, deformation ng bronze due to temperature plus deformation ng bronze due to the force. Okay? So if you substitute yung formula natin, so yung formula pag due to temperature, so that will be alpha times the delta T times yung length ng ating steel plus yung ating deformation due to the force, so that is PL over AE. So that will P times length over area over E. So this is for steel, okay? Both steel. So that is equal to yung deformation ng ating bronze due to temperature, so that is alpha times delta T times yung L ng ating bronze plus yung deformation due to the force ng ating bronze. So that will be PL over AE ng ating bronze. Tama? So if we substitute all the given, so substitute natin yung given, so that will be 6.5 yung each steel rod, 6.5 times 10 raised to negative 6 yung kanyang alpha. So that will be 6.5 times 10 raised to negative 6 times yung delta T natin. So that is 100 degree Fahrenheit. Okay? So times 100 times yung length ng ating steel. So that is 2 feet. So multiply natin ng 12 para maging inches siya. Okay? So that will be 2 times 12 plus yung force ng ating steel. Tama? Times yung length niya, that is 2 times 12 then, over yung area ng ating steel. So yung area ng ating steel given 0.75 times yung kanyang modulus of elasticity, which is 29 times 10 raised to 6. So that is equal to, so for the right side, that is yung for the bronze, yung alpha niya, that is equal to 10 times 10 raised to negative 6. So 10 times 10 raised to negative 6 times yung delta T, which is 100. Yung length niya is 3 feet. So that will be, i-convert natin sa inches. So multiplied by 12. 3 times 12 plus yung force ng ating bronze. And yung length niya, that is 3 times 12 maging inches. So yung area, given din yung area, that is 1.5 inch squared times yung E. So given yung E, that is 12 times 10 raised to 6. Okay? So meron tayong equation. So we can simplify this. So if you simplify this, we will get 0.0915 force ng steel minus 0.1667 force ng bronze, that is equal to 1,700. Okay? So you can directly input it in your calculator or isa-isahin ninyo. So ito yung rin yung lalabas. And for equilibrium equation, so we can say this as equation 1. And for equilibrium equation, kung ito yung ating black, no? So this is, meron siyang weight na 12 kilopounds, or that is 12,000 pounds. Okay? So magkakaroon tayo dito ng tatlong force. So yung force ng ating steel, force ng ating bronze, and force ng ating steel then dito sa left side. So for equilibrium equation, so summation of forces vertical is equal to 0. So that will be equal to upward positive. So that will be equal to force ng steel. So dalawa yan magkabilaan. So this will be 2 multiplied by 2 plus force ng bronze is equal to a minus. So downward yung 12,000. Ilipat na natin sa kabila. So that will be equal to 12,000 pounds. Okay? So meron na tayong equation number 2. So we can substitute yung ating force ng steel into the equation 2. So we can substitute any, yung equation 1 to equation 2 or equation 2 to equation 1. So we can solve simultaneously yung ating two equations. So we can calculate the force sa steel. So that will be equal to 8,700 pounds, and yung force natin sa bronze, that will be equal to negative 5,400 pounds. Okay? So, kapag negative sign yung bronze natin, negative sign, ibig sabihin downward siya. So, actually, itong bronze natin, downward yung direction niya. Tama? So, that will be downward. So, yung so, calculating the stress of each material, steel and bronze. So, sabi natin, stress is equal to force over area. So, stress for the steel is yung force over area. That will be 8,700 pounds. And yung area niya is given 0.75 square inch. So, that will give us a 11,600 PSI. So, positive ya, kaya tension. Okay? And for the steel, for the stress in the steel, that is equal to negative 5,400 over 1.5 square inch. So that is equal to negative 3,600 PSI. So negative siya, kaya equal siya sa compression. So that will be 3,600 PSI. So this is compression. So these are our final answers.